Hello everyone, my name is Vyas Chidi, and today I'd like to start off by reading from an article written by Giada Ko in 2019, When Fossil Fuels Run Out, What Then? Ko states that our annual consumption of our energy resources increases by about 4% every year. This means that we will have depleted our energy resources, our oil reserves, in about 30 years, gas resources in 40 years, and coal resources in 70 years. But what happens after that? Well, the solution is quite simple. Solar energy. The sun has been around for 4.6 billion years and will be around for the next 5 billion years. This means that we have about 5 billion years worth of untapped energy at our hands. Today, though, I'd like to specifically talk about how solar panels are made, how sunlight affects them, and the various materials that have been developed to increase the efficiency of solar panels. According to the article written by Jacob Marsh, How Solar Panels Are Made in 2019, Marsh states that all solar panels are manufactured into two different types, monocrystalline and polycrystalline. Solar cells are made up of silicon wafers, which are composed of different elements, including boron, phosphorus, and silicon. When phosphorus is bonded with silicon and made into a wafer, these are called N-type wafers or negative type wafers because they have an extra electron. When silicon is bonded with boron, these are called P-type wafers or positive type wafers. And according to the article written by the organization ACS in 2020, How Solar Cells Work, when two oppositely charged wafers are put together, they create an electric field. These wafers also prevent from holes occurring in the silicon structure. But to explain how sunlight affects a solar cell, I like to introduce the analogy of a hydro dam. Imagine you have a massive hydro dam full of water, but without any holes. Now, as most of you know, a hydro dam works by converting running water into electricity through use of hydro turbines. But how would you create running water without any holes or the usual facilities? Well, imagine taking a simple rock and skipping it across the water. You would create a few ripples. But what if you took a massive boulder and threw it into the water? This would create a wave that would ripple over the edge and create running water. A solar cell works in a very similar way. The dam itself represents the silicon structure inside a solar cell holding all of the electrons and potential energy, which in this case would be the water. The boulders represent photons, which are particles of sunlight. And the more photons you have, the more boulders you have, the more running water you have, or the more electrical energy you have. When sunlight strikes a solar cell, electrons are ejected from the silicon structure, which creates holes in the silicon structure. And when there are holes, electrons are forced to move through layers back and forth. And this flow of electrons is what creates electricity. Furthermore, through various research and developments, scientists have realized that different materials can yield a higher and more efficient solar energy absorption, like copper or different metallic substances. According to the Shockley-Queisser limit, a mathematical theory, states that the maximum efficiency for a solar cell made up of only silicon is about 30%. But according to the article written by Padraig Belton, A Breakthrough Approach for Solar Power in 2020, Belton states that when 6 or more substances or materials are put together, this can increase the efficiency of a solar cell to about 47%. In conclusion, we have discussed how solar panels are made up of various materials, including silicon, phosphorus, and boron, how solar energy can be converted into electrical energy through the movement of electrons, and lastly, how different materials in solar panels can yield a higher efficiency under concentrated light. Thank you.